Okay, good morning. So the next one I want to move on to is what's known as the alkali metals. And the alkali earth metals, if we remember, these are group 2 elements. So group 2 elements, these are the group 2 elements that we have on the periodic table. Now I'm just going to focus on one of these group 2 elements so we can kind of get an idea of the chemical reactions that happen in relation to the group 2 elements. So the one that I'm going to focus on is this one here. It's magnesium. So what I have here, I just have the Bohr structure for magnesium. Now, if we remember the Bohr structure, so it tells us about the arrangement of the subatomic particles. So the subatomic particles are inside here in the nucleus. You have the protons, which are positively charged, and you have neutrons, which don't carry any charge at all. Now, if we remember, it's the number of protons, and that number is 12. So we can see on the periodic table here, the number of pairs is 12. That's what distinguishes one atom from another. And in the case of magnesium, it has 12 protons. And each proton carries a positive charge, so it has 12 positive charges. Then outside here in the shells or orbitals, we have the smaller, what are known as the electrons, and if we remember, they carry a negative charge. Now remember, in a neutral atom, you have, if you have 12 protons, for example, in the case of magnesium, you also have 12 electrons, and the 12 electrons are spread out in these shells. So the first shell, this is the one that's closest to the nucleus, it can contain 2 electrons. So we can see here with magnesium, it has 2 electrons. The next two shells out from the nucleus, they can contain up to 8 electrons. So if we see here, so 2 of them are in the first shell, we have 8 of them in the second shell, and then in the third shell we only have 2 electrons, and that accounts for the 12 electrons that an atom of magnesium has. Now, if we remember, um, well, like what drives a lot of chemical reactions is this idea that atoms want to have a full outer shell. So either they can gain electrons from another atom, they can share electrons with another atom, or they can lose some of their electrons. And the idea is that they want to get a full outer shell. Now, in the case of magnesium, in order for its outer shell to be full, it needs to have 8 electrons in its outer shell. Now, if we look at this shell here, its outer shell, we can see that it has 2 electrons. So it can either gain 8 electrons from another atom, which is very hard to do, but the easiest thing for magnesium to do is just to give away these 2 electrons. And this, just like if we think about, so group 2, remember when it's whatever group it's in, so it's in group 2, the 2 also represents the number of electrons that the atom has in its outside shell. So all of these atoms, let's say that are group 2 atoms, which are known as the alkali earth metals, they all have 2 electrons in this outer shell. And this makes them very reactive. So what they want to do is they just want to give away these 2 electrons. Now, magnesium is a very, very important metal. It's actually quite malleable. So if we have a look here, so this is magnesium, and it's quite a soft metal and it's very, very malleable as well. Now, magnesium is a very, very important element. It's used in many different ways, but one really important way that's very fundamental to our survival, let's say here on the planet, is through the process of photosynthesis. So if we think about photosynthesis, so what happens is you get light that's coming from the sun. Now, if you think about the sun is 92 million miles away. It's away in the depth of space, and it sends radiation in the form of sunlight to us, to the earth. And what happens is you have plants, any plants that contain green, which is nearly all of plants, they're able to take the light from the sun, they're able to soak it up, and they're able to use that light and change it into food. So they can make carbohydrates that make up the structure of the plant, and they use that as food for themselves. But we also use that as food, and we also use that to feed livestock and feed animals as well, which produces the majority of the food that we get here on the earth. So it's very, very important. Now, not only that, but plants also, through the process of photosynthesis, they're also able to take in what's known as carbon dioxide. So this is a gas that we breathe out as waste, but plants are able to suck up this carbon dioxide, and in the process of photosynthesis, they can change this carbon dioxide into oxygen. And that's where a lot of the oxygen that is produced in the earth, that's where we get it from. We get it from the process of photosynthesis. It comes from other places as well. Plants are not the only animal or are not the only organisms that are able to produce oxygen. There are other organisms that can photosynthesize and produce oxygen as well. But if we think about, so the green part in plants, it comes from this chemical that's known as chlorophyll. And chlorophyll looks something like that. Now it's a bit complicated. I don't expect you to know the arrangement and everything of it. But if we have a look at it, so you can see here, so we can see there's carbons, there's lots of carbons, there's oxygen, inside here there's nitrogen, and then in the middle then we have a magnesium atom. So this is a chlorophyll, like this is a structure of chlorophyll, and this is kind of like what it looks like. So the plant is able to use this structure in order to harvest the energy from the sun, from the light from the sun, and then it can use that then to drive the process of photosynthesis and change, for example, that you can use the energy in sun, and it can take up, the plant then can take up water and carbon dioxide. It takes up water in its roots and carbon dioxide into its leaves, and then it can combine them and make carbohydrates, and then it also produces oxygen as well. But the whole mechanism that drives that, the energy that's used to do that, is taken from the sun, and the only way the plant can do that is by using this molecule chlorophyll. And what's absolutely central to chlorophyll is this element, magnesium. This is a key element that makes this whole little structure work. So without magnesium, for example, the plant is not able to capture the energy from the sun. And it's quite an amazing process when you think about it. You have this huge fireball that's in the sky, that's in space, 92 million miles away in the depth of space, that's sending all this light our way. And the only way that we're able to get and use some of this energy is by eating, for example, plants. They capture the energy, and we can eat plants, and we can take the energy out of the plants through carbohydrates, or we can use the plants then to feed livestock, for example, and then they can be used then as well as food, or to produce other food sources as well. But what's pivotal, or what makes this whole process happen, is this molecule called chlorophyll, which is the green part. It's what produces the green color in plants. And what's absolutely central to this molecule being able to work is this magnesium as well. So it's a very, very important element. And again, it's just to kind of re-emphasize as well, when you look at the periodic table, all of these elements are part of a structure in some way or another of everything around us, including ourselves and including plants and all other animals and all other materials as well. Okay, so back then to the reaction then of the alkali metals. So again, they'll all react the same way. They have 2 electrons in their outer shell, and what they want to do is they want to lose these 2 electrons. And generally what they'll do is they'll lose the 2 electrons, and then they'll become a charged particle. If we remember, a charged particle is what's known as an ion. So if we think about if magnesium loses the 2 outer electrons, it's going to become, so imagine this is your magnesium atom, it's going to be charged, and it's going to have a +2 charge, because when you lose 2 of these electrons, you're going to have more positive charge coming from the nucleus. You're going to have 2 more positive charges coming from the nucleus, so it's going to have a +2 positive charge. So let's have a look at one of the reactions, and this is quite a violent reaction, and it's when you burn magnesium in oxygen. So again, this is a very violent reaction. When you burn magnesium in air, for example, the air contains oxygen, it'll burn very, very bright. So magnesium, for example, they can take magnesium. So if we have a look, so remember, this is what magnesium looks like, and they can actually grind this up into a fine powder, and they can put it into fireworks, for example. And when heat hits magnesium, what happens is it burns extremely bright. And they also use it in flares as well, flare guns. Again, when magnesium is ignited in air, when it's lit, what happens is it burns very, very, very bright. And that can be used to produce a lot of light in the case of flares, and it can light up or illuminate a particular area. The same with fireworks as well. It's used in fireworks because it burns very bright, and it produces, some of the colors as well that are produced in fireworks that I'm sure you've all seen at some point. So let's have a look. So what we're looking at here then, so if we take, again, this is just the chemical formula. You have magnesium plus oxygen gives you what's called magnesium oxide. So that's just basically where the magnesium atom and the oxygen atom are combining together. The oxygen molecule are combining together to form a magnesium oxide. So this is just a simple chemical formula. If we have a look here, it's a little bit more complicated, but it gives a little bit more detail. So it's the same thing, but it's just given a little bit more detail. Now, if we remember, on the left-hand side here, you have what are called the reactants. So these are the atoms that come together and they react. This arrow here indicates that these two react, the reaction goes this way, and this is your product. So you have the reactants are magnesium and oxygen. Now you'll notice also as well, see there's a small s and a small g here. That just means that it's magnesium in a solid form, and then you have oxygen which is in a gas form, which is in the air. This small 2 indicates here that there's two oxygen atoms and they're bonded together. And then here you have magnesium oxide. So you see here again, when these two combine, when these two atoms combine, magnesium oxide is produced, and this is produced, it's a solid, okay, when it's produced. So if we have a look here then, so all we're looking at here are the Bohr structure. So this is the Bohr structure for magnesium. So it just shows the configuration of the electrons. So you have these shells, you have 2 electrons out here, you have 8 electrons in this outer shell, and then in the very outmost shell you have 2 electrons. Now we have oxygen here. So again, you can see that oxygen has 2 electrons in this shell, and then it has 6 electrons in this shell as well. So really, like, oxygen wants to get 8 electrons in the outer shell. So what it wants to do is it wants to receive 2 electrons. And magnesium, on the other hand, it wants to give away 2 electrons. So in order for it to have an outer shell of 8 electrons. So what happens is, if you take magnesium, which is in solid form, so it's like this, and if you add a heat to it in here, what's going to happen is you're going to get a very violent chemical reaction will happen. And what causes that reaction is the movement of the electrons. So basically what's going to happen is the electrons in the outer shell of magnesium are going to jump, and they're going to attach on to the oxygen atom, and they're going to attach on out here. Now what happens is, when magnesium loses 2 of its electrons, it becomes positively charged, and it gains a +2. It becomes a positively charged ion. So it'll have 2 less electrons within its electronic configuration. So as a result of that, the positive charges coming from the nucleus will be able to come true, and as a result of that, it'll have a plus, or a 2 plus positive charge. Now, when oxygen gains these 2 electrons from magnesium, it's going to have more electrons in its outer shell, or within its electronic configuration, than it has positive charges within its nucleus. So therefore, it's going to become negatively charged. So it's going to be a negatively charged ion. So it's going to have, it'll have a -2 negative charge. And then what will happen is, so this will become positive, this will become negative, and the 2 of these atoms then will join together. And if we remember, this kind of arrangement, where we have 2 charged particles joining together, is what's known as an ionic bond. So this is an ionic bond. So essentially what happens is, the movement of electrons creates a positively charged ion in the case of magnesium, and a negatively charged ion in the case of oxygen. And the 2 of these join together, and they form magnesium. They form magnesium oxide when these 2 join together. And again, as I was saying, it's a very, very violent chemical reaction. So I'm going to show you a video here. And basically it's a firework factory in China. And so basically what happened was, the magnesium, there was lots of magnesium, so magnesium like this, but it was ground up into like a powder, and they use magnesium to produce fireworks, for example. But anyway, the magnesium caught fire, and as a result of that there was a huge fire and a huge explosion. But again, what's happening here, this explosion, is this chemical reaction happening here. You have solid magnesium that's burning in oxygen because of the heat, and it's producing magnesium oxide. But this process, it not only produces magnesium oxide, but it produces a huge amount plus, a huge plus energy. So energy in the form of sound, energy in the form of light, and heat. So think about when you watch this. So you have a huge explosion. You can hear that. There's loads of light, as you can even see in the video there. There's loads of light being produced, and then if you were anywhere near that, you would feel the heat as well. And again, these are all forms of energy. And all of this energy is coming from, like, what's producing all this energy is the movement of these electrons. So you have electrons moving from one atom to another, and they move very quickly, but this causes a huge violent chemical reaction. And this is basically what you're going to see now is this process happening. You get two atoms turning into ions and then fusing together, and it's changing these reactants into product, but then it's also producing huge amounts of energy as well. So let's have a look, and we will leave it then at that.
I'm videoing it. What the
I think that might be a gas station or something.
I guess. Whoa! Oh! What the? No! No, baby! No!
Are we dangerous here?
Yeah, we're dangerous. Oh my God!
Oh dear! Are you filming?
Yes, I'm filming.
Whoa! Whoa! I think we are dangerous.
Let's go! Let's go down! Let's go!
Let's go! Take the stairs!
Come on!
Okay, so as you can see and hear from the video, lots of excitement and lots of energy and heat and light being produced as well. But again, the basis of that, like what you're observing there, is that chemical reaction happening. So these are the group 2 elements, and we've just looked at the example of magnesium and how it reacts in relation to oxygen. And if you take all of these other group 1 elements as well, so beryllium, calcium, strontium, all of these elements as well will react in a very, very similar way to magnesium. And so once you kind of know how one reacts, you have an idea of how all of the rest of them react as well. Okay, so guys, thank you for listening, and I hope you enjoyed the video, and thank you.